In the previous video, we were estimating the value of employee stock options, and we were demonstrating how to implement not the first snippet of code, but the second snippet of code. So I'm going to take this code and introduce it into the VBA Visual Basic Editor in Excel. That's already done, and I've done it in this particular video. And then the last step relates to just the implementation of the function. So we put in the parameter values, and we then take the name of that function. So it's a user-defined function. If we would like to check, go into the Developer tab and look at the Visual Basic Editor, and we would note that the code here is the code that we took from the portal here. Okay, so it's the second snippet of code, VBA code for Hall and White 2004 with refinements for Boyle and Lowe 1994. It's that snippet, second snippet of code there. Okay, so we're in Excel. We're going to call up the function dynamic truncated Hull White Boyle Lowe, okay, which is basically Hull White 2004 model being implemented with just a revamp for the barrier implicit in Hull White 2004, and then dynamic use. So we truncate the zero region, we truncate a region above the barrier or the multiple, and we use dynamic memory, and that's from Brody to Temple 1996. Okay, so it's if we come up here to fx, then that will prompt the arguments to appear here in the function arguments, and which is very simply the stock price, the exercise. Now everything is put in order. So time period, the maturity of the option is 10 years. The vesting period is the initial period within which the holder of the option cannot exercise the option. So that could run, that's obviously for a shorter maturity than the full maturity. And in this case, we're saying 5 years. The risk-free rate, it is risk neutral valuation, and we're adhering to the FASB principles of valuation. Sigma is 20%, and the dividend rate we're going to take as being 0.02. The exit rate is equal to 4%, and then M, the multiple. So when the stock price exceeds the original exercise by 1.5 times that magnitude, then Hall and White specified that the option exercises early. And N then is the number of steps. Okay, and we already have a value that's popping out here, 2257. Okay, so question then is, are we happy that that's value is correct? So we can, what we might do there is we can go to the actual paper, SSRN paper, accounting for employee stock options, accelerating convergence, download it. I have it open here. And on table 5 we took some values obtained by Steve Wiener, who kindly provided us with some true values, but he said if we take these parameter values, okay, copy, then which were parameter values set out in the Siventik Wiener Zapatero paper of 2008, then the true value is 27,885. Okay. Okay, so what we do, we go to the SSRM paper that we've made available on that portal, accounting for employee stock options, accelerating conversions, and we downloaded that. We copy these parameter values that we obtained from Civentic Finer Zapatero, and we can see here true values, and the true values were actually values that Svi Wiener emailed to us when we were writing this paper. He made available these true values, which turned out to be quite practical. So we want to we can paste those values here, and in addition we put in a dividend rate of equal to 0. Okay, so that's the other. Okay, so I'll pause and populate, and we've entered those values in the various cells, just 3 minor changes. And if we just drag across the user-defined function, we now get 2786. So if we go back to our paper, you can see here, well, we have 500 steps, and the true value, of course, is 2785.5, so that's quite close to 2786. If we had put in Boyle 27 at 500 steps, with hull white Boyle at 500 steps, that answer, the output we should get in Excel is 2786.75. So let's just check that. Okay, so put in 500, and we get 2786.74.6, but of course with a little bit of rounding, 75. Okay, so it seems to be consistent. Again, if we put in 1000, just to make the comparison, we can observe it's quite fast, and that generally for other types of binomial implementations you don't get the same level of speed. But that's 278530. Let's take a quick look. 25.8, so 278530, which is consistent with what we have here, 278530 for 1000 step tree. Now again, if we went into the original implementation of hull white model at 1000 steps, we would just get 2828, which is fairly substantially away from the true value. If you notice here at 1000 steps, we're very close to the true value, which is good, but with the original implementation, that doesn't have any specifications that accelerates estimation at 1000 steps, we would be 2828.24. If we take, just to demonstrate a little bit the impact of using this dynamic code, if for instance I had loaded in, if I take this, which is not recommended, if I had taken this code, let's just copy, so this is the static code with no acceleration technology, no truncation incorporated in, no dynamic memory, and I copied that into again the spreadsheet, so I could create a new module, new, insert, module, paste, and we can, the order of the variables is the same here, so we just have to remember the name of the function ESO. And if we took this set of parameters here, and then we read in the name of the function, so it's prompting here for ESO, that's the user defined, and then FX, and we went through the same set of steps, the stock price is 100, the exercise is 100, the time period is 10 years, the vesting period is 2, the risk-free rate is equal to 6%. Pull down drag down the menu bar. The sigma here is 20%, the dividend rate is equal to 0, the exit rate is equal to 4%, and the multiple 1.5, and the number of steps is equal to 1000. Okay, so we've included that in. Once we click OK, one of the things we'll notice here is that the estimation takes longer. So it's 28. So just if we change this to 1001, the output is almost instantaneously. If I change this to 1001, I've hit return, I'm waiting, and it just takes a longer period of time for the estimation, maybe as much as 10 seconds, whereas this within 2-3 seconds. And that's also a positive of using dynamic memory. This function uses dynamic memory. It truncates the tree. We use a lot less nodes. We can dispose of many nodes in the tree. It's quite efficient, whereas this one is static and not nearly as fast. Okay, so we might also note here the result that we get with 1000 steps, or 1000, and if we go with 1000 steps and come back here with 1000 steps, okay, 2785 as opposed to 2828. Okay, so yes, we get 2828 using whole white, but that's a long way from true. That's the true value, and of course that's a fairly significant shortcoming of using the whole white 2004 model without making adjustments for the barrier. That we get a lot of oscillation when we map out our results here and compare the whole white model. It takes a long time to converge, whereas with the whole white Boyle already within 500, 1000 steps, we're close to true. Okay, and that's a major advantage. Okay, next video we'll look at some of the parameter sensitivities here, and we'll address why are those important. Well, FASB standards, right, impose a certain number of recommendations in terms of what has to be taken into account, in particular the expected volatility, the time period, the vesting, all those factors, the stock price, the exercise, all those factors have to be incorporated into whatever model we use to fulfill our accounting obligations and to arrive at a fair value estimation for the employee stock option or for the grantee stock option. Okay, so we'll take a look at that in the next video.